Good morning, good afternoon, good evening. This is Math with Mr. Samuels and Ms. Burnell. Just like usual, make sure that you have the notes so that you can follow along with the video. And let's go. Let's roll. So today we're talking about the Pythagorean theorem. Okay. You both classes, you guys did some discovery activities, and hopefully you saw exactly how the Pythagorean theorem works. But if you did not, this should clear up any misconceptions that you might have. So when we're dealing with the Pythagorean theorems, we are dealing with right triangles. And here are the parts of a right triangle. We have side A, side B, and we have side C. Now, sides A and B are always known as the legs. Okay, and side C, this longer, bigger side, is always known as the hypotenuse. Okay, hypotenuse. So, just like you guys saw in class, the Pythagorean theorem can only be used when dealing with right triangles. Okay, so the formula for the Pythagorean theorem is a squared plus b squared equals c squared. And some of you all might be wondering, where do we get these letters from? Where do we get these sides from? This side squared plus this side squared should equal this side squared. Okay, so let's do an example or two. Okay, so first we have this first right triangle here. This side A is 12, side B is 5, and it looks like we're trying to find side X, which is side C, which is the hypotenuse. So we square 12, we square 5, just like I did in my formula here. Okay, and 12 squared is 144, 5 squared is 25, and x squared just stays x squared. And we follow our order of operations. We do that. We add 144 plus 25, which gives us an answer of 169. And now some of you all might be thinking to yourselves, well, how do we get rid of this square? Well, when we're solving equations, we always use the inverse operation. So the inverse operation of squaring something would be to find the square root. So we find the square root of both sides. So the square root of x squared is just going to be x, and the square root of 169 is going to be 13. So what we find is that our final answer ends up being x equals 13. So this side length over here is 13. So let's do another example. Let's look at number 5. On number 5, we have side A is x, side B is 8, and the hypotenuse is 10. Okay. One thing I didn't say to you guys, just as a quick reminder or a quick clear up, okay, the hypotenuse is always going to be the side that is across from the right angle. So it's always going to be the side that's across from the right angle. Okay. So clearly in this example, we're trying to find one of the legs. So I'll plug everything into my formula. A squared plus b squared equals c squared. We have x squared plus 8 squared, the other leg, equals the hypotenuse squared, so 10 squared. So 8 squared is 64, 10 squared is 100, and now we just have to solve the equation. So I have to get rid of this 64 first. So I'll subtract 64 from both sides, and 100 minus 64 gives me an answer of 36. Now, just like we did with the example above, when we have x squared, we need to get just x by itself. So we use the inverse operation of squaring something, which is finding the square root. So the square root of x squared is going to just simply be x. And what we do to one side, we have to still stick with the golden rule. What we do to one side, we have to do to the other side. So the square root of 36 is now going to be 6. So this missing leg over here turns out to be a side length of 6. Okay? Now, the last example that I want to do with you guys is determining or testing for a right triangle. Okay? Now, when we're testing for a right triangle, we are still going to be using the Pythagorean theorem. But notice that they give us all three sides at the beginning. So what we need to do is plug all of those numbers into the Pythagorean theorem to determine whether or not it gives us a true statement. If it does give us a true statement, then we know that it is a right angle. If it does not give us a true statement, then it is not a right triangle. Okay, so let's go ahead and test this out. So, first example, we have a side length of 10, 15, and 20. Now, notice I labeled all of the different lengths. I said that 10 centimeters is A, 15 centimeters is B, and 20 is C. Now, some of you all might be thinking to yourself, how do we determine this? How do we determine this? Well, we determine this by whichever is the longest side. That has to be our hypotenuse. That has to be our side C. Okay, so on all these different examples here, whichever is the longest side, that is our side C. Okay, so let's go ahead and do this example. So we have 10 squared plus 15 squared should equal the hypotenuse, which was 20 squared. So when we square all of those different things, we end up with 100 plus 225 equals 400. Oh no,